Let's focus more on electrical energy and talk more about electrical circuits. We're going to start our exploration with electrical circuits by looking at some students from England who are exploring with the components of an electrical circuit.
The children are going to look in a box of components that they've been given to make circuits. A circuit is a path that electricity goes through and is made using components. Components are just things that can go in a circuit, such as batteries, wires and bulbs. Listen to the children try and describe the components. How would you explain what they do?
This is the buzzer, and the buzzer makes a sound when the electricity passes through it. This is the bulb holder, and it holds the bulb when you screw it in. This is a bulb, and you put them in one of the bulb holders. And when the circuit is switched on, all the electricity passes through to the bulb, and the bulb lights up.
This is a switch that switches the buzzer or the light bulb on.
This is a battery, and it has power inside, and when it goes through the circuit, it can make the light and the buzzer work.
The crocodile clips clip onto the things, but the electricity travels through the wire to the next thing you want it to travel to.
In order for a circuit to work, it needs a power source. Batteries are easy sources of power to use in some electric circuits. Let's learn more about the parts of a battery.
Batteries supply electricity. They have a positive terminal, shown here by a plus sign, and a negative terminal. The children are looking at toys that use batteries to see how they fit in.
There's a plus sign on the batteries and in this toy, and there's a takeaway sign in this toy. This is the positive side, and that's the negative side.
Batteries supply electricity. This side is the positive side and this side is the negative side. And in this Game Boy, it tells you where they should go.
Batteries come in different sizes to fit different devices.
My battery is a little different from Granny's and Luke's because it's a fat cuboid shape. It has one with a little necker or collar around it and one with just no necker or collar around it. This is the negative side and this is the positive side.
In science this week, we've been learning about electrical circuits. Let's explore more. Notice we have an electrical circuit in front of us. You'll see a power source, which is a battery. But right now, our light bulb is not lit. We're missing something in our circuit that will not allow it to work properly. Let's explore with some of the resources at the bottom to see if we can help make the circuit work properly. First, we'll start with an eraser. The light bulb didn't light because the object we chose did not conduct electricity, which means it did not allow the electrical current to flow through it. Let's try another. Let's try a key. This one worked. The key allowed the electricity to flow through it. Let's explore some more. This time, we're going to try filling the gap with other objects to see which ones will allow electricity to flow and which ones do not. This is a piece of chalk. Let's see what happens. This does not allow the electricity to flow. Start thinking about what the objects have in common that allow the electricity to flow and the ones that do not. Let's try a rubber duck. Nope, no electricity flowing yet. Let's try another object. Oh, a battery. Let's see what happens when we add another battery into our circuit. The light bulb lit brighter. This is because more electricity and more electrical current is flowing through our circuit. Let's try another piece of wire. This allows our light bulb to light, but not as brightly as last time. Our electricity and our electrical current is flowing from the battery all the way down to the light bulb. If we add another light bulb, do you think it will light? Yes, both of our light bulbs work, except they're very dim, and this is because we have two objects that are using this one power source to work. Try a piece of cork. That stops the electrical current from flowing. Last but not least, let's try a coin. This allows the electrical current to flow. Why do you think the coin, the key, the wire, the light bulb, and the battery all allowed electricity to flow through the circuit? Let's learn more about conductors and insulators. Conductors are materials that allow heat, electricity, and/or sound waves to pass through them. Metal is a good conductor of heat. Heat from the stove can easily pass through metal pots. This heat cooks the food. Energy like heat, electricity, or sound can easily pass through a conductor. While our investigation didn't involve heat, it did involve electricity. And so we noticed that all of the materials that allowed electricity and the electric current to pass through in order to light the light bulbs, all of those had metal on them or were made of metal. These were all conductors. Here's some examples. Each one of these objects is a conductor of electricity. You'll notice as we put them in our circuit, each one of them helps the light bulb to light and completes the circuit. Insulators are materials that prevent electricity or heat from passing through. Have you been shocked by an electric wire? What can we use to keep electric currents in the wire? Rubber is a poor conductor, which makes it a good insulator. It is used to cover wires that connect appliances to the wall socket. Insulators are what help to prevent the electricity from flowing out and also keep us safe from electrical currents. Here are some examples of insulators in our investigation. Each one of these objects is a good insulator. Let's talk about switches and how switches are important for electrical circuits. Turn the light on. Now turn on the TV. You have just used two switches. When you switch the light and TV on, you close an electrical circuit. Electricity flows. The light bulb glows and your favorite TV show is on. When you switch them off, the circuits are opened. The electricity can't complete its flow. The light and the TV stops working. This is a diagram of a switch. Pay close attention to the areas that are circled in red. On the top, we have a normal looking switch. It's currently in the off position. Take a look at the image on the bottom. Notice that there is a part of the circuit that is open. meaning the pieces of metal are not connected. If this happens, the electrical current cannot flow through the circuit. When I switch the light switch on, it closes the metal pieces so that they're touching, which allows the electrical current to flow through and the light bulbs to light. Here I have a simple electrical circuit. If it works properly, this red light right here should turn on. Right now, it's not turning on. Think about why that might be happening. You may have noticed an on-off switch in the middle. If I switch it to on, notice how the red light turns on. This means that the electrical current from the batteries is able to flow all the way through to the light bulb and back to the batteries again. But when I turn it off, it stops the electrical current. It's almost like I took scissors and cut a wire. Notice if I turn it on and unhook this piece here, it stops working. Why is that? We've created an incomplete circuit. And right now, the electrical flow from the battery cannot go all the way to the light bulb because there's no piece connecting it. If I put this back on, the light bulb comes back. Let's check back in with the students from England and see how they were able to create electrical circuits.
The children are drawing a complete circuit. It will need to include a source of power, such as a battery, a device that uses electricity, such as a bulb or buzzer, and something that will connect the power source to the device, such as a wire. The children are now going to make the circuit they've drawn using components from the box.
I'll screw this in. Another battery. Put that here. Oh, there it is. It's done it. This is a complete circuit.
A switch opens and closes a circuit which will turn a device, such as a buzzer, on and off.
Energy cannot be created or destroyed, but it can change form. Let's talk about how energy can change from one form to another. Try clapping your hands together. As you clap your hands, you'll notice a few things about energy. First, as you're moving your hands together, that's motion energy. When your hands come together, they create sound energy because the motion energy is transformed into sound energy. You might also notice air moving from your hands. This is another form of motion energy. Take a look at this example of converting energy. Electric energy converts to heat energy, which causes the ice to melt. The heat energy, when applied again, causes the water to boil and turn into steam. When applied again, the heat energy converts into motion energy because the steam causes the cork to pop off the bottle. Take a look at this circuit. There are several forms of energy that are being converted in this circuit. Look closely to see if you can identify those forms of energy. Let's talk about the forms of energy that you identified in this video. First, you'll notice the fan. The fan takes electrical energy from the batteries and converts it into both motion energy and light energy. If you listen very carefully in the video, you'll notice that the motion energy converts into sound energy. It makes a very low whirring sound. Electrical circuits and energy conversions are all around us. As you watch this video on your television or computer, think about the conversions of energy that are taking place. We start with electric energy that converts to light and sound energy. Many devices contain small fans that convert electric energy into motion energy to keep the device from overheating. It is extremely important to remember safety when working with electric devices. Talk to an adult before exploring any of the devices in your home. Keep magnets and water away from electronics to protect you and the device from harm.